Right into completing the square. And you guys are lucky because I'm already a complete square. So that's the way that we do things. Just kidding. Okay, when solving quadratic, completing the square is a technique for solving quadratic equations. Quadratic equations, right? It's a technique for solving. Now, we had talked about previously about several other methods that we can do to solve quadratic equations. Okay, when they are factorable, we can use this thing called the zero product property. And remember, that looks like x minus 3 times x plus 5 equals 0. What numbers make this true? Well, we factor it, we write it as a product, and then we say, all right, well, this is true if x minus 3 is equal to 0 or x equals 3. And this is also true if x equals negative 5. So that's the zero product property. We can also solve equations if they look like something squared equals a number. Okay, and those we can solve by taking the square root of both sides and thinking of the positive and the negative case to get our solutions, okay? And then I said there are a bunch of quadratics that aren't factorable, and you can't take the square root as they are currently written. And those are ones that, so the things that don't fall into these categories, these are the ones on which we can complete the square. Okay, so an example of one would be like this: x squared plus 4x minus 5. All right, so this one equals 0. This one, can we find factors? Oh, that one, gosh dang it, that one does work. So how about this? Minus 15. Can you find factors of negative 15 that add to 4? And there aren't any, okay? It's not possible, but it turns out that this thing still has 2 solutions that we can find, and we're gonna be able to do that with completing the square. And we can't take the square root here either because the b is not equal to 0, right? We need this term to be away, to go away for us to be able to take the square root. So we're gonna be learning completing the square today. All right, before we begin, or before we really get down, we're gonna get things going. So we did the bump there, right? I was like, hey, look, here's what we got. We got the set coming up. The spike is coming up here in just a minute, where we're gonna get things going to complete our volleyball metaphor. Let's take a look at this equation. It's already factored, but we don't have 0 on the right, which is a problem. So there's a couple ways we could do it. It says solve it by taking the square root. So this is something squared equals a number, which means I can take the square root of both sides of the equation. Okay? Take the square root of both sides of the equation. Now remember, when you take the square root, you have to consider the positive case and the negative case. There's x equals 2, and there's x equals negative 2. So to save time, from now on, I'm just gonna write plus or minus 2, especially on this lesson. Okay? So let's take a look here. Let's take a look. So take the square root. The square and the square root cancel out, and all we have left is x minus 4 equals plus or minus the square root of negative 25. Well, the square root of negative 25 from our last lesson we learned was an imaginary number, and this will be 5i. 5i is what that is. It's the square root of 25 times negative 1, okay? Still not solved. We want it to be x equals, add 4 to both sides of the equation, plus 4, and you'll get 4 plus or minus 5i. So those are our 2 solutions to this quadratic equation. And if I were to plug 4 plus 5i, so 4 plus 5i is 1, and 4 minus 5i is the other one. If I were to plug those in here, we would get our 2 solutions that make the equation true, which is kind of exciting. So there is a square root there. I'm going to clear that off so you can see the original problem. So I took the square root of both sides of the equation. All right, you guys can try this next one if you feel like it, or you can unpause the video or just keep watching. Square root both sides yet again. This is something squared equals a number. So we end up with x plus 3 equals the square root of 3 over 25. Now, anytime you take the square root of a fraction, you can take the square root. I almost forgot my plus or minus. So don't forget that. You can take the square root of the top and the square root of the bottom, so you can kind of break it apart. I can't take the square root of 3 and get a whole number answer. It'll be irrational, but you can't take the square root of 25. Square root of 25 is, this is x plus 3 equals plus or minus the square root of 3 over 5. So we get x equals negative 3 plus or minus the square root of 3 over 5. Oops, let me clear that up a little bit. Sweet. Yep, subtracting 3 from both sides. So there's our two solutions there. Cool, hopefully that's making sense. So we're still, as part of as the bump set spike, we're still doing the set, still in the set process. So we can solve something like this by taking the square root. All right, can we take the square root here is the question. And as of right now, we cannot, because we have this 10x term, right? That's getting in the way. That's a problem. Now, I'm going to do this a different way first. I don't want you to write the first way down. So the way that I write in red, don't write down. The way that I write in blue, I want you to write down. So if before, when I gave you this, I would have said, all right, we want to get everything on the left, and we would have subtracted 36 from both sides. Don't write this down now. I see you reaching for your pencil. Don't write it down. And you get x squared plus 10x minus 11 equals 0. X squared plus 10x minus 11 equals 0. Is this factorable? Can you find factors of negative 11 that add to 10? And yes, we can. They are x plus 11 and x minus 1 equals 0. So we could use the zero product property here to get our two solutions. X equals negative 11. I'm going to write them down here. X equals negative 11 and x equals 1. But there's actually another way to do this problem. And the other way, so I'm going to leave those down there. The other way to do this problem in blue, this I do want you to write down, is to recognize that this thing on the left is factorable. Well, that doesn't help us because we need 0 on the right, Mr. Slagle. Not if you're doing the square root. Watch what happens. Are there factors of 25 that add up to 10? Yup. X plus 5 times x plus 5 equals 36. So this can be factored. 5 and 5. 5 times 5 is 25 and 5 plus 5 is 10. So we just found the two things. You'll notice that this is conveniently x plus 5 squared. So now I have just taken a quadratic that is not using the zero product property. I took the left side and I turned it in what's called a perfect square trinomial, right? I wrote it in its factored form and it had the two of the same factors, so we could write it as x plus 5 squared. Now this question is just like the questions I was doing before. It looks like something squared equals a number, which means I can take the square root of both sides of each side of the equation. Oh, that is horrendous on my eyes. Oh, gosh, don't do that. Square root. It's weird. I'm just going to do it over the top. Over the top. Okay. Square root of x plus 5 squared is, and I'm probably not going to show that step anymore, is x plus 5, and then we have plus or minus 6 is our answer there. So x equals negative 5 plus or minus 6. So negative 5 plus 6 will be one solution, and negative 5 minus 6 will be the other. So our two answers are 1, and negative 5 plus 6 is 1, and negative 5 minus 6 is our negative 11. Bingo. Look at that. Amazing, 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 amazing. All right, see if you guys can do it on this one on the right. I'm going to do it real fast in just a sec. Is the left side factorable? Yep. We can find factors of 49 that add to negative 14. That'll be negative 7 and negative 7. So it'll look like x minus 7 times x minus 7 equals 81, which is actually just x minus 7 squared is 81. If you take the root of both sides, you end up with x minus 7 equals plus or minus 9. That comes from taking the square root there. We can add 7 to both sides, and you'll get 7 plus 9 and 7 minus 9. So our two solutions will be 16 and x equals negative 2. Boom. All right, so look. Here's the deal. That was, you were saying, Mr. Slagle, what the heck? Your math is not impressing me. That's what you're saying to me, okay? Because you made it so we could, this isn't helping us. These are like specifically constructed so that they would turn into x minus 7 squared so we could take the square root. You're not impressing us, Mr. Slagle. That's what you're thinking in your brain. I'm doing a teaching method that's called scaffolding. It's where I'm building you up to the more complicated idea. If you can understand these steps, then you can understand what we're about to do, because we're about to do some math shenanigans here in just a sec. So you're going to notice that anytime we have a linear binomial squared, there is a pattern. This one turns into x squared, right? Because this is x plus 2 times x plus 2, right? So we had to like distribute it out. It turns into x squared plus 2x plus 2x plus 4. This one turns into x squared plus 5x plus 5x plus 25. And this one turns into x squared minus 3x minus 3x plus 9. So what's the pattern? Well, the pattern is that when you multiply these out, you always get the same term in the middle, and you end up adding them together. So you really just take this number and double it, and that's what's going to ultimately end up being your middle term when you're done, okay? And here, this will be x squared plus 10x plus 25, and here it'll be x squared minus 6x plus 9. So what's the link? What's the pattern? What's the pattern? Can I do this in reverse, right? Can I take this and turn it into the original thing? Like, for example, if I said x squared plus 16x plus blank came from this, right? So we squared something, some number with x, and we ended up getting x squared plus 16x. Now, this is actually enough information. If this is a perfect square trinomial, that means if we know that it's something squared, I already know what that number is because of this 16, right? Here, look at the relationship. 25 is 5 squared, 9 is negative 3 squared, and 4 is 2 squared. So all we have to do is kind of split this into its two chunks, right? Split it in half, 16x, or 16 split in half is 8, and then square that. So that means this thing on the inside is 8, because it'll be 8x plus 8x, and then you square that to get the last number, which is 64. Hopefully that makes sense. So let's take a second and practice completing these. I'll do a couple of them, and you can do I'll do the outer ones. You guys can do the middle ones. So I'll try this. So this is the act of completing the square. This thing that I'm doing here. Okay. The relationship is interesting. So let's take a look. How do we complete the trinomial if this is what we have? Well, we take this thing and we divide by 2 and then we square it. And it turns out that in your notes, you have this formula, and that's what we're doing effectively. You take this middle term, you divide by 2, and you square it. So this will be, in this case, negative 8 divided by 2 is negative 4 squared will be plus 16. 18 divided by 2 is 9, and 9 squared is 81. And in this one, 5 divided by 2 is 2.5. Squared is plus 6.25. And then here we have negative 0.75, or if you're doing if you didn't want to write these as decimals, which I guess maybe we want to be accurate or something, we can do it as a decimal. Now I'll do it as a fraction as well. So this will be 0.75 divided by 2 squared. Here you'll get, it's kind of a nasty-ish decimal, plus 9 over 64. So we'll just leave it like that. And then here, this would be 5 over 2 squared, which is 25 over 4. 25 over 4 is 6.25. Okay, find the missing value to complete the square. So you just take that thing, divide by 2, and then go to town. So here's the rule. Here's the rule. If you know what b is, then you can write what this is to complete the square, and you can factor it immediately. So this is what we just did. I gave you this, b, and then you wrote the completing term. So what is it in factored form? Well, you just take this step, the b over 2, and that goes on the inside, and that's it. So we can actually factor these as well. What's b over 2? It was negative 4. So this is x minus 4 squared. What was b over 2 here? It was x plus 9 squared. So these are equal to those things, right? b over 2 here was x plus 5 over 2 squared. Yay! And then right here, this would be x minus 3 over 8 squared. So I just did 0.75 divided by 2, or 3 over 4 divided by 2, which is the same as 3 over 4 times 1 over 2, which is 3 over 8. Bingo. All right, enough jibber jabber. Let's do an example. Let's complete the square. So here are the steps for completing the square. Step 1, put the constant on the right. Put the constant on the right. What's up? Here we go. This is going to be x squared minus 12x. Oh, man, I got to sit up straight. Posture is key. Equals negative 5. So I subtract 5 from both sides there. Step 1 complete. Step 2. Step 2. I'm even color coding them for you. Add b over 2 squared to both sides. Add b over 2 squared to both sides. So let's go ahead and calculate b over 2 squared. b over 2 squared is equal to, b is when I'm looking at like a is 1, b is negative 12, c is, in this case, 5, but we only need b. So this is going to be negative 12 over 2 squared is equal to negative 6 squared, which is 36. All right, so I'm going to come down here and I am going to add 36 to both sides of my equation. Why 36? Well, you're going to see in just a sec. Okay, what we're about to do is some serious math shenanigans. serious math shenanigans. We are going to take this quadratic trinomial that, by the way, we can't solve by factoring. Can you find factors of 5 that add to negative 12? No, you cannot. No, you can't. But this actually has 2 real solutions. It's kind of exciting. It does. It has 2 real number solutions. So what we're doing is we're saying, you know what? I don't like this quadratic. I want to make it a little bit easier. So we push that ugly 5 out of the way and we say, let's live in a happy land where 36 is the number on the side. Well, hey, I can find factors of 36 that add to 12. Now, what allows us to do that, right? What we do to one side, we do to the other, right? We subtracted 5 from both sides here. I just added 36 to both sides. We're treating both sides equally. That's fine. So we say, I just forced the left side to be factorable. Factors of 36 that add to negative 12, piece of cake. That's x minus 6. By the way, it's always going to be this number right before you square. Equals negative 5 plus 36 is 31. And ladies and gentlemen, we have just taken this quadratic that was unfactorable. We couldn't take the square root, and we have forced it to be a quadratic that we can take the square root of. So I'm going to take the square root of both sides. So square root, and you'll get x minus 6 equals plus or minus the square root of 31. So my 2 answers are 6 plus or minus root 31. So 6 plus root 31 and 6 minus root 31. 6 plus root 31, 6 minus the root 31. Now, some students are going to look at that and they're not going to think it's actually 2 different answers. They think it's just 1. But it is 2, right? One of them is x equals 6 plus root 31. The other one is x equals 6 minus root 31. And root 31 is just some number. Let's take a look here. Root 31. It's 5.567. So if we do 6 plus root 31, you will get an approximate value, because now I'm rounding, of 11.57. And if you subtract, you'll get something plus. You will get x equals 0.43. Oh, shoot, it's squiggly equals. I flubbed it. It's approximately 0.43. Now let us do a quick reminder. Quick reminder here. Look at this. What does this mean? This is a quadratic, okay? We want to know where the quadratic is equal to 0. Well, what it really means is that we want to know where this thing crosses the x-axis. We want to know where its y-intercepts are. And oh, look at this. It's like someone had it this conveniently graphed in Desmos already. Who could have done that? Golly gee. Here's our quadratic. Where does it cross the x-axis? Gee, I wonder. Here, let me just move this up a little bit. Oh, this is inconvenient. Desmos, you're resized to the wrong size. Where does it cross, you might ask? Let's take a look. Hey, what? Desmos. Hey. There we go. 0.43 and 11.568 or 11.57. That's where it crosses. Bam. And we just did that with our brains, not with a computer. Deal with that. Except for that last part. We used a calculator. Just a little baby calculator. You could have done that on an abacus. Oh, you know what? I forgot to write the other steps, and I didn't change the color. I got carried away. Step 3 is you get to, so step 3 happened right here. factor the left side and simplify right. Yeah, all right. Sweet. And then we'll do red. And then the last step is right here. Step 4 is square root. And solve. Boom. Boom. Goes the dynamite. Okay, now I'm not going to write these steps out every time. I'm not going to change colors. We're just going to power through some problems. On your mark, get set, go. Here we go. How do I get started? Oh yeah, the steps that I just learned. Step 1, put your constant on the right. Sound effects, are they encouraged? Hopefully. Minus 36. Minus 36, minus 36. Great, constant on the right. Step 2. Step 2, add b over 2 squared to both sides. Let's go over off on the side. B over 2 squared equals negative 8 over 2 squared, which is negative 4 squared, which is 16. So I'm going to add 16 to each side. All right, that wasn't too bad. Now we are going to factor the left side, simplify the right. So we'll have negative 20 on the right side, and on the left side, we're going to have something that is to the squared power. What number times itself is 16 and adds to negative 8? Well, that is x minus 4. Now, remember how I also said this is very important because the next question is going to get you if you don't understand this. At this step, when you go from here to here, you don't really have to think about factoring. The number in here is always going to be b over 2. It is part of that formula that I give you. The number inside here is always just b over 2. So you just can just say, hey, what's negative 8 divided by 2? Oh yeah, that goes there. Bingo. Now we can take the square root both sides, and we'll get x minus 4 equals plus or minus the square root of negative 20. Oh, Mr. Slagle, is that why you taught us imaginary numbers? Because we're about to get imaginary solutions and complex numbers? That's right. That's right. Timmy. Oh, we actually do have a Timmy. Oh, and Timmy missed class today. Timmy, I hope you're watching the video. Let's simplify that. The square root of negative 20 can be simplified to 4 times 5 times negative 1, which is square root of 4 is 2. Square root of 5 is root 5 times I. Bingo. So this will be, our final solution will be, add 4 to both sides, 4 plus or minus 2 times the square root of 5 times the imaginary unit. What? Sweet. Awesome. You don't have to add those or calculate or approximate because they're simplified because that's a complex number. That's how they're supposed to be written. You guys try this last one. If you get stuck, unpause the video and watch. Yada, yada, yada. You get the picture. We can do this. Constant on the right. X squared minus 3x equals negative 5. Yes, 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 yes. Add b over 2 squared to both sides. Now I'm removing the scaffolding. We're removing the scaffolding. B over 2, well, that's negative. Maybe we aren't removing the scaffolding. Oh no. I think it would be mean for me to do that. I would lose some people. B over 2 squared, that's negative 1.5 squared, which is 2.25. Don't believe me? Try it on a calculator. 2.25 equals negative 5 plus 2.25. Oh, that's so fun. Okay, and now remember how I said the left side when you go to the factoring step? The number that's in here is always just b over 2. It's always just this thing. minus 1.5. And if you don't believe me, you could multiply it back out. Negative 1.5 times negative 1.5 is positive 2.25. Negative 1.5 plus negative 1.5 is negative 3, so it works out. This is negative 2.75, which is nice and fun. Square root both sides, and we'll get x minus 1.5 is equal to plus or minus the square root of negative 2.75. Oh, that's just beautiful. Beautiful. Add 1.5 to both sides, and we end up with 1.5 plus or minus the square root of, now I'm going to simplify this. This is a decimal, so just pull out the minus 1. This is 2.75 times negative 1 under the root, so we're going to pull out that, and we'll get 2.75 in the root I. Now, if you don't like this as a decimal, and you want to leave it as a fraction, that is perfectly acceptable and encouraged. That is encouraged. You can do that. And so 2.75, that would really be 2 3/4. Actually, you could just leave it as a fraction right here if you wanted. If I was really being like a good student in junk. Oh, that's brutal. Let's just turn that into, let's just turn 2.2 3/4, because then we'd have to do the subtraction all over again. That's really root 11 over 4. Break the root 11 in the top, square root of 4 in the bottom is root 11 over 2. Ooh, man, I just popped my back. Whew! 2 solutions. 1.5 plus the square root of 2.75i, and 1.5 minus the square root of 2.75i. Bingo! Or the square root of square root of 11 over 2i. I'm going to write that because I'm evil. Equally correct, perhaps even better answer. Anybody want to be a hero and save the Avengers? Then you should write your answers like that. Oh no. Oh no. What? Mr. Slagle, you lied. You lied to me. You said that you told me that completing the square works on any quadratic. It does. But be patient. Be patient. We must apply some math wisdom. This is true. We can only complete the square when a is equal to 1. So, we must make it equal to 1 by dividing both sides by a when it is not equal to 1. So this is for when a not equal to 1. Then we're going to do this thing. Let's have a practice. Let's have a practice. Uh-oh, can't complete the square. I'm throwing in the towel. Might as well give up now.
No, we have more that we can do.
Special effects are talking into my water bottle. And drinking from it as well. I can't complete the square on this because a is equal to negative 1. So what I'm going to do right off the bat is divide both sides by negative 1 to get x squared, oops, minus 8x minus 9 equals 0. Great. Guess what I just did? Did some math wizardry. I divided both sides by negative 1, 0 divided by negative 1 is 0, blah, blah, blah. Signs change. Now it's just like every other question we've been doing. We can complete the square, and I'm going to do so quickly. Minus 8x equals 9. Add 9 to both sides. B over 2 squared, removing that scaffolding. Negative 4 squared minus 8x plus 16 equals 9 plus 16. Add 16 to both sides. B over 2 squared, this is x minus 4 squared equals 25. Oh, easy money. 25 is a perfect square. Take the square root. X minus 4 equals plus or minus 5. I took the square root of both sides. looks like a 6. Plus or minus 5. And I feel like I need to be a good teacher and like write that square root step. Got him. All right, and then add 4 to both sides to get 4 plus or minus the square root of, or 4 plus or minus 5. Now, please don't write your answer like this. These are numbers, so our numbers are 4 plus 5 is 9, and 4 minus 5 is -1. Now, here's a little trick of the trade. If you get whole number, or sorry, integer answers like this, that means at the very beginning, this was factorable. It means that we could have used the zero product property. It means, even though I'm requiring you to complete the square on these, this whole assignment, that is important to note. It means that there are factors of -9 that add to 8, and those are -9 and 1. So that would also have worked. How about this one? Oh my God. It's horrendous. A is not equal to 1. A is equal to 3. So how about we change it and we make it equal to 1? Don't move the 18 over, because we're just going to have to move it back. So divide both sides by 3. Yes. We'll get x squared plus 4x equals 6. Yeah, now we're talking. B over 2 squared. This is x squared plus 4x, b over 2. 4 divided by 2 is 2. 2 squared is 4. So add 4 to both sides. 6 plus 4 equals, this will be x plus 2 squared equals 10. So then x plus 2 equals plus or minus the square root of 10. I think my computer is melting. -2 plus or minus the square root of 10 is what will give us our, yes. Oh, man, that's beautiful. All right, now this is 2 solutions. This is 2 solutions. We have 2 solutions here. One of them is x equals -2 plus root 10. I want everyone to practice plugging this in on their calculators. And one of them is -2 minus root 10. Now, root 10 is just some nasty, irrational number. It can't be simplified. It's not divisible by 1, 4, 9. So we can just approximate, or we'll do root. We can evaluate that on our calculator. -2 plus root 10 gives us 1.16 approximately, and -2, oh no, what did I just do? Math, escape, clear, off. I pressed the wrong button. There we go. -2 minus root 10 gives us this -5.16. Okay, sweet. Makes my day. So our answers are about 1.16 and 5.16. If we were to graph this, right, you'd be able to see that. All right, I'm pretty much done. I'm going to do one more. You guys try this last one. Give it a shot. Give it a shot for old time's sake. And then we'll go over the answer. Oh, it looks like this one's kind of gross. All right, let's do it. Divide everything by 2. Divide by 2. Divide by 2. I did that in the last one, right? Yeah, cool. 2 divided by 2 is 1, x squared. 3 divided by 2 is 3 halves x. I'm going to do this all with fractions because I feel like it's a little bit of a flex, but it's good practice. 0 divided by 2. Okay, so now we got to move the constant to the right. So we divided everything by 2. 3 divided by 2 is 3 halves. Let's do it with fractions. And that's where everyone just turns the video off. Don't turn the video off. Power through it. Come on. You got to save the Avengers. Save them. Don't leave them stranded. Okay, move the constant to the right. Add b over 2 squared to both sides. In this case, b over 2 squared is 3 over 2 over 2 over 1. Oh, that's gross. Skip, change, flip. This is going to be, I'll let you do the math. 3 over 4. 3 over 2 times 1/2. Or 3 over divided by 2 is the same as 3 over 2 times 1/2. Squared, which is 9 over 16. So we are going to add x squared plus 3 over 2, x minus 9 over 16 equals, or sorry, plus 9 over 16 equals 2 plus 9 over 16. Gross, man. Do we want to keep these answers exact? I think I'm regretting my decision. So this is x minus 3 over 4, plus 3 over 4, plus 3 over 4 squared equals 3 over 4 times 3 over 4 is 9 over 16, and 3 over 4 plus 3 over 4 is 3 over 2. This is 32 over 16 plus 9 over 16, which is, eeks. 32 over 16 plus 9 over 16 is 41. Gross. 41 over 16. Yeah, that's kind of gross. Why did I do this? It's not that bad. Square root both sides, and we'll get x plus or minus 3 over 4 is equal to plus or minus the square root of 41 over 16. Hey, I can take the square root of 16. That's not too bad. So our two answers are minus 3 over 4 plus or minus the square root of 41 divided by 4, because I can take the square root of 16. Oh, there we go. Hey, that was fun. We got our two answers, and they are not pretty, but we're going to love them anyways. All right. Thanks for tuning in to the Mathnasium. You too are now complete squares. All right, we'll see you guys later.